And now we're going to move on, and we're going to look at 1.6. And 1.6 is other types of equations. So we're going to look at several different equation types, and we're going to learn how to solve them. We've got some that will involve a square root. We've got some that involve fractions. And we've got some that involve fractional exponents or fractional powers. So we're going to go ahead now and start with the fractions first. And then we'll look at some applications. And then we'll learn about square roots. And finally, fractional powers at the end. So the first thing we need to worry about when we talk about equations and solve them is what are not solutions. So we need to figure out what numbers can't happen. And so we're going to look at our domain. And the domain is values of x, or values of the variable, that can be solutions. And what we want is no division by zero. Okay, so we cannot have division by zero. So when we talk about the domain, we're talking about values that could possibly be a solution. And what cannot be a solution is division by zero. So I'm going to give you some fractional equations, and we're going to talk about what values are not in the domain. So these are going to be finding the values that are not in the domain. We're going to be looking at values that are not in the domain. So we're going to start with this one. So let's say I give you 3x plus 4 over x minus 2 plus 5 over x equals 4. We're not going to be solving this. We'll learn how to solve these in a moment. But right now, what we're looking for is the values of x that are not in the domain. And so what we cannot have is division by zero. So what we're going to look at first is our denominators. We're not worried at all about the numerators. We're only worried about the denominators. And so what we're going to do is we're going to set each denominator to 0. Oh, yeah. Sorry, that's plus 5 over x there. Sorry about that. Yep, that should be an x there. Okay, so what we have is we've got 3x plus 4. Yep, no problem. I'll try to make it a little bit bigger too. Okay, so we've got 3x plus 4 divided by x minus 2 plus 5 divided by x equals 4. So we're going to set each denominator to 0. So x minus 2 equals 0. And we're going to add that 2. And that gives us then x equals 2. And that 2, if I were to plug that in, look at what would happen if I plug back in that 2. If I plug that 2 into this first fraction, I have 2 minus 2 in the denominator, and that gives you a 0 down below. Can we have any number divided by 0? No, because that's undefined. That's not possible. So x equals 2 is not part of the domain. What about the other one? On the other one, there's nothing down below except an x. So x also cannot be 0. So what do we know about the numbers that are not in the domain? The numbers that are not in the domain are positive, 2, and 0. So they are not in the domain. So 2 and 0 are not in the domain. They are not possible values of x because they would give you division by 0. Sometimes you may have to factor as well. So let's find another one here to work through. And again, same directions. Find the values not in the domain. And this is going to match up with a couple of questions in your homework. This is going to match up with questions 18 through 20. So homework 1.6, 18 through 20. I'm going to give you another one to look at here. This one you're going to have to factor. How about 5 over x squared minus 4 plus 3 over 7x minus 5 equals 10. Now, again, we're not solving these yet. What are we doing? We are finding the values of x that are not in the domain. So we look at our denominators, and we set each denominator to 0. So that's going to be our next step. Set the denominators to 0. So what do we have for our denominators? Well, our first one we've got x squared minus 4 equals 0. That's going to factor because that is a difference of squares. Why is it a difference of squares? Because 4 is a perfect square of what? 4 is a perfect square of 2. So that's going to factor down into x plus 2, x minus 2. And then we have x plus 2 equals 0. So x equals a negative 2. That can't work. What about the other one? X minus 2 equals 0. So that would give you x equals positive 2. That can't work either. And what about our other denominator? What's our other denominator here? Our other denominator is x minus 5 equals 0. And so what would not work for that one? When I move it over, 5. So what numbers are not in the domain now? The numbers that are not in the domain are going to be minus 2, positive 2, and 5. Those are not in the domain because those would give you division by 0. Right? Because if I plug in, let's just take one. If I plug in that negative 2, what happens when I square negative 2? It becomes a positive 4, right? And 4 minus 4 on our first fraction would give you a 0. And can you take 5 divided by 0? Can that happen? No. So that's why negative 2 is not in there. Positive 2 doesn't work either. And 5 also can't happen because 5 minus 5 gives you what? 0 down below as well. So that's how you find the domain. And the domains are just values of x that do not work. Now we're going to learn how to solve some of these. And there's a step-by-step procedure to solve these rational equations. And rational equations are just equations that involve fractions. So here's our step-by-step procedure. And we're going to be solving rational equations. Step number 1. Find the values not in the domain. Step number 2, clear fractions. Step number 3 is solve. And step number 4 is just check and make sure that your answers are in the domain. So check all possible solutions with step 1. Okay, so it's a pretty straightforward way of solving these. So we can see it again. We're going to try to solve rational equations, and these are equations that have fractions. First thing we do is we find the numbers that do not work. Then we clear our fractions out, and then we solve it. And then we need to go back and check all of our solutions with step 1. And if they're in step 1, that means it's not a solution and it doesn't work. So we need to make sure that these answers work and do not give you division by 0. So we're going to do 2 of the simpler ones first, and then we'll do 2 of the more complicated ones after that. So I'm just going to pick these from our textbook here. And I'm on page 164. We're going to look now at question number 20. So we're going to look at question 20. And we've got x over x minus 4 equals 4 over x minus 4 plus 4. So this is what we've got. And let's go through our step-by-step procedure. What's the first step? We find the values of x that will not work. So when we look at these, we've got these two fractions. And what do they have in the denominator? X minus 4. So for step number 1, let's see which number is not in our domain. So we're going to take our x minus 4 and we're going to set it equal to 0 now. And we'll add our 4. And so x equals 4 is not in the domain. And why is that not in the domain? Because that would give you division by what? 0, and we don't want that. So we just have to know what it is first. Now we're going to clear our fractions. So step 2 is clear out the fractions. And how do we clear out our fractions? Well, we clear out our fractions by multiplying everything now by what? We're going to multiply everything by what's in our denominator? X minus 4. So we'll multiply everything now by x minus 4. That's going to clear out all of our fractions. So the x minus 4's, they cancel, and that leaves you with an x. The x minus 4's, they cancel. That leaves you with a 4. And the last one we have 4, nothing to cancel out. So that's 4 times your x minus 4 there. Is everyone okay with how I cleared the fractions? We're with that so far. Now we're going to distribute through. We're going to solve it. So now we're on to step 3. We're going to solve it. So I'm going to distribute that 4 through. And now we have x equals, on the left, we've got 4 plus 4x minus 16. Combine your like terms and rewrite it a little bit neater on the right. So that's going to be x plus 4 on the right. Then we've got 4 minus 16, leaves you with a minus 12. We're going to move that 4x over. And that leaves you then with a minus 3x equals a minus 12. We'll divide by our negative 3. And then that gives us x equals now what? 4. Okay, now, here's where students make a mistake. Is 4 going to be my answer? No. Why not? Why is 4 not going to work? Because it gives you division by 0, right? So x equals 4 is not going to work, and so we have no solution. And why do we have no solution? We have no solution because 4 is not in the domain. It goes back to step number 1. So you have no solution. Okay? That's why. Because if I plug that 4 back in, or look at it, what do I have? 4 gives me division by 0. I can't have it. The only solution that I got was 4. So that tells me then that this equation actually has no solution. Let's try another one. Question 24. This one's going to make us factor quite a bit. So question 24, we've got 3 over x squared plus x minus 2 minus 1 over x squared minus 1 equals 7 over 2x squared plus 6x plus 4. Okay, so this one we're going to solve out the same way that we did the last one. We're going to have to factor out each of these denominators first. So we're going to begin by having to factor and work through each denominator. We're going to factor these denominators. So we've got x squared plus x minus 2. Well, first times the last is a minus 2. That tells me one number is positive, one number is negative. Larger number is going to be positive, so I can use a 2 and a minus 1, can't I? Remember how to factor these? So that would then factor down into x plus 2, x minus 1. Is everyone okay with that? So just normal factoring, nothing new there. What about our next denominator? Our next denominator is x squared minus 1. Well, that again, just like the previous one, is a difference of squares. So as a difference of squares, that would factor into x minus 1 and x plus 1. And what about the last one? Last one, we've got a 2x squared plus 6x plus 4. So what can I factor out of it? Well, when I look at my 2, 6, and 4, these all are multiples of what? Multiples of 2, aren't they? Okay, so a 2 is in common. So I'm going to factor out a 2. That leaves me then with x squared. When I factor out a 2, plus 3x plus 2. And we can factor it and finish it as well. Okay, 1 times 2 is 2. What two numbers multiply together to give you 2? Add together to give you the 3 in the middle. Well, that's going to be 2 and 1, right? Because 2 times 1 is 2. And 2 plus 1 is that 3 in the middle. So that will then factor into 2 times x plus 2, x plus 1. So this one does take a little bit more time just to factor it. The hard part, though, is all done now. So let's now take everything that we've got and try to put it all back together. So when I rewrite this, we've got 3 over x plus 2, x minus 1. That's that first piece, factored down. We have a minus 1 over x plus 1, x minus 1. And then we've got our equals, and on the right-hand side, we've got that 7 over 2 times x plus 2, x plus 1. So the first thing that we needed to really do was factor everything down as far as we can go. Now we can finish it. So now we've got all these different denominators to work through. So we factored these out. So now what numbers are not in the domain? We look at each one independently. So x plus 2 equals 0. That gives you x equals a negative 2. Right? Because that would give you division by 0 here. We can't have that. What else can't we have? Well, on that same one, we've got x minus 1 equals 0. Moving it over. We also can't have 1, because that would give you division by 0 there. And then what do we have left? We've already done the minus 1, x minus 1 here. We've also got to add in that x plus 1. And x plus 1 equals 0. That gives you x equals a negative 1. That can't work either. And then we don't have to worry so much about the last one. Why not? Okay, the 2 is just a multiple out in front, so it doesn't matter. What are our two parentheses? We've got x plus 2, which is here. We've got x plus 1, which is here. So what numbers now are not in the domain? And the numbers that are not in the domain, we've got several of them. We've got minus 2, minus 1, and 1. Those numbers are not possible solutions. So all the hard work is now done. The easy part is what we're going to look at next. So we've figured out what numbers can't work. We factored it all the way down. So most of the work is done. Now we need to see how to clear out these fractions. So this is step 2 here. Clear out these fractions. And we need to look at this as a whole to figure out what we need to get rid of everything. And we'll do this one piece at a time here. Okay, so we're going to have to multiply this entire problem by something to get rid of all of our fractions. So first off, let's look at our first fraction. So what do we need here? Well, down below we have an x plus 2 and an x minus 1. So we're going to need an x plus 2, x minus 1. What else do we need? On the next one, we've already taken care of the minus 1. We also need an x plus 1. And then what else needs to be gotten rid of down below? 2. So now this is going to be distributed through. It looks more complicated than what it really is. So let's take our time and see what we've got. Well, what do we have when we distribute? We've got a 3 on top here, so that stays. Now what cancels out? When we look here, the x plus 2 cancels, right? Those cancel. The x minus 1s cancel. And so what's left over then? We've got the 3. And what else do we have? we have a 2 times an x plus 1. Because everything else went away, didn't it? All that canceled out. Now moving on to the next piece, we have a minus 1. There's no 2, so we've got a 2 left over as well. And what about here? Well, the x plus 1 and the x minus 1, those can cancel, can't they? So what are we left with? We're left with 2 times what? 2 times x plus 2. And then finally on the other side, we have a 7. And what's going to cancel out here? Well, we've got the x plus 2 is gone. The x plus 1 is gone, and 2 is gone. So we've got everything gone except for what? X minus 1. So that's going to stay there with the 7. Now we can finish it. So let's go ahead and combine like terms and distribute through. So 2 times 3, that makes it a 6 times x plus 1. Minus 1 times 2, that makes it a minus 2 times x plus 2. The other side, we'll go ahead and distribute that 7 through. And so the other side, then on the right-hand side, that becomes a 7x, watch your signs here, minus 7. Okay, now we can distribute that 6 and that negative 2 through and simplify down our answer. So now we've got, when we distribute through, 6 times x, that's a 6x. 6 times 1 is a 6. We've got minus 2x. And minus 2 times positive 2, that makes it a minus 4. Other side is still 7x minus 7. Almost finished. 90% of the work is done. Go ahead and combine like terms together. So 6x and a minus 2x, that makes it a 4x. And 6 minus 4, that leaves you with a positive 2. And that equals 7x minus 7. Move that 7x over. And move that 2 over as well. So 4x minus 7x, that makes it a minus 3x. The 2's can cancel. The 7x's can cancel. And that equals then a negative 9. Divide by a negative 3. And that leaves you then with x equaling now 3. So, is 3 a legitimate solution? Yes or no? Does anyone know? Is 3 going to be a possible solution? Is 3 going to work for it? Yes. What numbers will not work? If you came up with the numbers minus 2, right, when we work through, if you came up with minus 2, minus 1, or 1, you would have no solution. But ours is 3, and 3 is in the domain, so it is a solution. So your answer here would be x equals 3. I wanted to pick one that had a solution and one that did not have a solution, so you can see the difference. Now let's try one where we're going to have to factor to solve it. Let's look now at about question 35. So I'll write it up here. And we'll just do one of these more complicated ones. That way we don't run out of time. So we're going to look at question 35. And this again is on page 168. So we have 2x over x minus 2 equals 5 plus 4x squared over x minus 2. So again, we have fractions, so we need to find the number or numbers not in the domain. And you can probably just look at this one and tell that 2 is not going to be in the domain. Why would 2 not be in the domain? Because if I plug in 2, I have 2 minus 2. And what does that give you down below? 0. Can we have division by 0? No. So you can either look at it or just write it out as x minus 2 equals 0, which gives you x equals 2. So that is not in the domain. Is everyone all right with that? Does everyone see what I did there? Now let's clear out our fractions. So step number 2. We've got 2x over x minus 2 equals 5 plus 4x squared over x minus 2. Now we need to clear out our fractions. So the only thing that we have in the denominator on each of these is what? The only part we have is an x minus 2. So to clear out our fractions, all we need to multiply everything by is a what? X minus 2. That should clear out all of our fractions because that's the only thing that we have in our denominator. So now we're going to clear out our fractions here. When we distribute through those 2x, or sorry, that x minus 2 is going to cancel with the 1 below. So that leaves you then with a 2x for your first piece equals, now there's nothing to cancel with the 5, so that's going to be 5 times x minus 2. And then what about the last one? Well, the x minus 2s, those cancel. Right? Those directly cancel. And that leaves you with a 4x squared. Does everyone see how I cleared those fractions out? Because that's what you had in the denominator. So that's all you need to multiply it by. Now, this one is going to give us 2 possible solutions, and we're going to have to factor it. So distribute that 5 through. That leaves me then with 5x minus 10 plus 4x squared, and that's on the right, and a 2x is on the left. Okay, let's go ahead and set this to 0. So move that 2x over, and let's rewrite it so that it's in the correct order. Highest power of x always goes first. So rewriting, we've got our 4x squared, that's our highest power. And we've got a 5x minus 2x, that leaves you with a 3x. And then we've got our minus 10, and what's the other side going to be? Well, it's going to be 0, isn't it? So everyone see how I move that around. So just rewrite it so it's in the correct order. Now, always what do we want? Highest power first. You could either use the quadratic formula or you can factor it. This one I think is going to be very easy to factor. So we're going to take the first number times the last number. And 4 times a negative 10 is a negative 40. So what do we know? We know this is negative. So that tells me then that one number is positive, one number is negative, doesn't it? And what about the middle? Middle's positive, so our larger number is positive, smaller number is negative. It ends in a 0, so that means we start with 5, multiples of 5 and 10. So let's try, 10 obviously is not going to work for us. Let's try 15. 40 divided by 15. It doesn't go in there. Let's try, 5. Let's see, 40 divided by 5, what's that going to give you? 5 and 8. So we need a positive 8 and a negative what? 5. That's going to work, won't it? Now, can we jump to our factors yet? No. Why not? We have to do an extra step because of this 4, right? And because that 4, we have that 4 in front, what do we have to do? Split the middle and factor by what? Factor by grouping. So 4x squared, then we've got, splitting up that 3x, we've got an 8x, and a minus 5x, and a minus 10. What can I factor out of the first two pieces? We're going to be factor by grouping. We did this back in 4-1. I know it may have been a bit, but we need to remember how to factor. These both have a 4 and an x in common, so that comes out. And that leaves you then with an x plus 2. The next two pieces, it begins with a negative, so I'm going to factor out a negative 5. And that leaves you then with an x plus 2. Those are the same. So now we have an x plus 2 out in front. Gone and gone, right? And what's left over? 4x minus 5. And that equals 0. And I know these take a bit to go through. Some of them are a lot easier than others. Finding the domain is not difficult. These, though, some of them take a little bit of time. So what are our final numbers that could work? We've got x plus 2 equals 0. So one possible solution is negative 2. Now, is negative 2 going to work? Yes, it will. Okay, why is negative 2 going to work? What number will not work? Let's go back up and look. What number is not in the domain? Positive 2, right? Positive 2 doesn't work, but we got a negative 2, so it works. We check that one with step number 1. We got to go back and check. What about the other one? Well, the other one is 4x minus 5 equals 0. So 4x equals 5. Divide by your 4. And so x now equals 5/4. And is that one going to work for us? Yes. Because what number will not work? The only number that won't work is positive 2. So negative 2 worked. And same thing with 5/4. It also worked. Now we're going to look at some quick applications. Then we'll take a break and we'll come back and we'll finish up 1/6 hopefully. These sections take a lot of time to go through, and that's why I split the first chapter in half, because there's just so much material in the first chapter. It goes a lot faster in chapter 2 and 3. But chapter 1, there's just so much material crammed in. I think it works out better if we split it in half. So let's now look at a couple of applications, and these are work problems. All right, so we're going to look at question 37, and this is on page 165. Now, when we look at these problems that involve work, we need to figure out how much work is done per unit of time. And they're very simple once you see how to set them up. So they're going to be much, much easier than the ones out of 1-5. So let's look at question 37. If Joe can paint a house in 3 hours, and Sam can paint the same house in 5 hours, how long does it take them if they work together? So we want to figure out how long it's going to take them working together. So let's draw a diagram here and look at each painter. So we've got Joe and we've got Sam. And this is on page 165, question 37. Now, Joe can paint the house in 3 hours. So how much of the house can be done in 1 hour? What fractional part of the house is done in 1 hour? If it takes him 3 hours to paint it, then in 1 hour he's done a third of the house, right? Now what about Sam? Sam takes longer, so he takes 5 hours to paint this house. So how much of this work, how much of the house is painted in 1 hour for Sam? If it takes him 5 hours to paint it, then in 1 hour he's painted what? 1/5 of the house. Now they're going to work together, so they add. And our time, we're going to call this X. And this is addition since they're working together. So let's now look at what we've got. We've got Joe. It takes him 1/3 of an hour. So that's going to be 1/3 X. Then we have Sam, and it's 1/5 X. And then how many houses are we going to paint? 100%, right? So we always make that equal to 1. Always 1 or 100%, because you're going to do 1 complete house. So all of these are going to equal 1 or 100%. Now we can go ahead and clear our fractions and finish it. So easy to solve from here. How do we clear our fractions? Well, we have a 3 and a 5. So the least common denominator is going to be 15. So distribute through that 15. And 15 divided by 3. Okay, 15 divided by 3 is a 5x. 15 divided by 5 makes it a 3x. And 15 times 1, well, that makes it 15. Adding these together, then we've got 8x equals 15. We'll divide by our 8. And so now we get x equals 15 over 8, or we can even write that as a mixed fraction. Or we could write that as 1 and 7/8, and that's ours. Now let's see if that makes sense. Okay, so let's look at this from a logical standpoint. Now, Joe can paint this house in what? Joe can paint this house by himself in 3 hours. So that means if he has a helper, what's going to happen to the time? It's got to be less than 3, right? Because if he's got a helper, it's got to be less because there's someone helping him. We've got 15/8, which is 1 and 7/8 hours. Now, is that less than 3? Yes, so it makes sense for our question. So I would take 15/8 or I would take 1 and 7/8. Either one is fine, or even the decimal equivalent. Let's try another one of these. Question 41. Now this one's got addition and subtraction in it because you're adding and subtracting the water here. So let's look at question 41. So we're going to try to fill a pool. So an inlet pipe can fill Blake's pool in 5 hours. An outlet pipe can empty it in 8. In his haste to surf the internet, Blake left both pipes open. How long did it take him to fill the pool? So he's got water coming in and water draining away. So let's go ahead and draw a diagram to represent that. So we've got water coming in. And how long does it take us to fill this pool? Well, it says to fill the pool, it takes it 5 hours to fill. So what does that mean? That means 1/5 is filled in 1 hour. You always make it back to 1 hour or 1 minute, whatever your unit of time is. In this case, it's hours. So in 1 hour, we'll do 1/5 of this pool. And we're going to fill up this pool, but we're also at the same time going to be emptying the pool. And so this is going to be the drain, and it takes it 8 hours to drain. So how much of this pool is drained in an hour? We're going to use a 1/8. I'm going to make this negative because it's draining. So you're taking water away. Our time again is going to be an x. So we've got water coming in as positive, water going out is negative. Now what's eventually going to happen? You've got water coming in faster than it's draining out, right? Because 1/5 is obviously bigger than 1/8. So what eventually is going to happen? Eventually we're going to overflow this pool. So let's see how long it takes to start overflowing that pool. So now we're going to look at the fill part. It takes 5 hours to fill, so that's 1/5. So that's going to be 1/5 x. Now the drain, we're going to use a negative. And how much of the water is lost to the drain every hour? 1/8. So that's going to be 1/8 x. And what does it equal? It equals 1. Why does it equal 1? Because that is one pool, or 100%. So that's what we've got there. Now, how do we finish this? Well, we need to clear our fractions. So how do we clear the fractions? We've got a 5 and an 8. So the least common denominator is going to be a 40. So go ahead and distribute through. And 40 divided by 5 makes it an 8x. 40 divided by 8 makes it a minus 5x. 40 times 1 makes it a 40. And we're almost finished here. That makes it then a 3x equals 40. We'll divide by our 3. And so now we have x equals 40 over 3, or 13, and it looks like, I think 1/3, because let's see, yep, 39 would be 13, so we can rewrite this as 13 and 1/3 hours. And that makes sense. Why does that make sense? Well, we know it takes 5 hours to fill this pool, right? But if you're also draining it out, what's that going to do to my time? That's going to make my time substantially more. So we know if it was just filling it, it only takes 5 hours. But if you're draining it at the same time, it's going to take longer. We got that to come out to be 13 1/3 hours, or 13 hours and 20 minutes. And that's longer than the 5 hours, so it makes sense for this question. So let's now go ahead and take a short break, and then we'll come back, and we will try to finish up, or at least get most of the way through 1.6. So let's meet back here at about 8:35. So try to meet back here around 8:35.